Before this lesson begins, it is important to restate what has already been talked about as a prerequisite for this content. And at this point in the lesson series, you should be very familiar with terms like perfect cubes, like how 8 and 27, for example, are both perfect cubes. 8 is 2 to the third power, and 27 is 3 to the third power. So these are called perfect cubes because they can be expressed with the power of 3. That is one thing you should be familiar with for what we're about to talk about. Another thing that you should be familiar with is the concept of power over root as it pertains to rewriting a radical expression. So for example, if you had, let's say the 7th root of x to the 9th power, then you would rewrite that as x as a base to the power of 9 over 7 because 9 is the power and the 7 is the root. And the 9 is going to go in the numerator, and then the 7 is going to go in the denominator. And this is another skill that has been talked about so far that you will need for the upcoming videos. Let me just clear this workspace out of the way. Need a bigger eraser for that. There we go. Erasing a little too much there. Getting a little behind the scenes on how this stuff works. And the last thing that you should be familiar with before we begin is how to simplify an expression like x to the 13th power, and let's say we're taking the 4th root of it. So we're taking the 4th root of x to the 13th power, and you're not rewriting it. So it's not x to the power of 13 over 4. We're not doing that procedure. Instead, we are simplifying it. So we have to think, since we're finding the 4th root of x to the 13th, how many multiples of 4 go into 13? And if you immediately went, 12 is a multiple of 4, then you were thinking of the right number. And since 12 is 1 away from 13, we would think of this problem as x to the 12th times x to the 1st, and we're taking the 4th root of that. Just divide your exponents. The 4th root of x to the 12th is x cubed, and then because the x to the 1st power, that 1, is not anything we can simplify with, then a 4th root of x is what would come out as the final answer to that. Not a bad problem to make sure we have practice, but we're about to see that same skill pop up in what we're about to do. So let's just go ahead and get into it. Number 1. So take a moment, maybe write down the notes. You can see the title. We are just rewriting rational expressions and radicals. We're going to be doing a lot of simplifying with the skills that had just appeared with what I went over with you, and maybe set up these examples, maybe even try doing some of numbers 1, 2, and 3, and then watch as we explain. So I'll give you a moment to just pause and set that up. Okay, and here we go with number 1. So there are many ways to approach these problems, but as a general rule, you want to always work, start spelling that wrong, from the inside out. Start with what's under the radical sign and simplify anything that you can. If it's a fraction, reduce the fraction. If there's one of the exponent laws, then apply the exponent law. But as long as you're working from the inside out, you're probably going to be on the right track. So with number 1, we have a fraction problem, and I'm seeing we have an x to the 1st power in the denominator, and there is an x to the 6th power in the numerator. That is just the same base dividing rule, where because x to the 6th is in the numerator and we are dividing it by x to the 1st power, you are just doing 6 minus 1 to get 5 as that new exponent. So an x to the 5th power is what would be written in the numerator. Likewise, there is a y to the 10th in the numerator, and you are dividing it by y to the 5th. So just do 10 minus 5, and you will have y to the 5th power in the numerator. The fraction 3/4 cannot be simplified anymore, and we're taking the 5th root of the entire thing, so we can now bring the 5th root symbol back into the problem and now do a little more simplifying. So here's what you should notice. We are taking the 5th root of x to the fifth power and y to the fifth power. We want groupings of 5 when it comes to our x's and our y's, but we have an x to the fifth power. We have one group of 5 x's, so we are allowed to remove it from the fifth root symbol, and since we are removing one group of x to the fifths, then only one x is going to get written down with the next part of the final answer. And the same idea goes with y to the fifth power. You already have a grouping of 5 y's, and we're taking the fifth root. So this one grouping of 5 y's can be removed from the radical and brought to the front. It comes out as a single y, and now we can write the rest of the problem. Everything else, the 3 and the 4, the 3/4, that stays under the fifth root symbol because we couldn't reduce it anymore. So you can write that in front. I suppose you could also write it behind the y. It doesn't really matter. Just the x and the y are no longer under the fifth root symbol because we were able to simplify them by taking their fifth roots because there were 5 of them. Basically, just notice, you divide those exponents. 5 divided by 5 is 1, and you would get 1s for both of those exponents. Just to further the point, if let's just say it had been an x to the 15th power, then I would have written an x cubed because 15 divided by 5 is going to be 3. So that's the main idea. And just maybe one more to make sure you got it. If this said y to the 25th power, then what would be the power on that y? It would be 25 divided by 5, which is a 5. All right, number 2. So in number 2, we don't have a fraction that needs to be reduced. There is nothing that we need to really work on from the inside out. We just have to be aware that we are looking for a perfect fourth. And what you should be familiar with is that 16 is a perfect fourth. 16 is 2 to the 4th power. And that is one of the perfect fourths that you should be aware of. There aren't too many perfect fourths and fifths that you need to know, but 16 is the perfect fourth that you need to know. Maybe highlight that somewhere in your notes so that it stays in front of your face when you need to see it. So the fourth root of 16 is going to come out of the radical as a 2 that would go in the front for our final answer. Next, the x, we're rewriting these in exponential form, by the way. That was something I should have said at the very beginning. But we are now going to do a little bit of power over root rewriting because I see we have an x to the 6th and then a y to the 11th, and the power is 6, and the root that we are taking is 4. So you can see by using power over root that we would have x to the 6/4 power. And that was a concept that was explained a little bit more in a previous video, but we're not going to dig too much into it right now. The 11 is also going to be the numerator, and then you're going to see the denominator being the root. So when we rewrite y to the 11th power, we would rewrite that as y to the 11/4th power. And since 6/4 can be reduced to 3/2, we can rewrite it. And maybe you're saying, well, why didn't we do the breaking up thing that was done with number 1? Just to keep things straightforward for the rest of these examples, I'm just going to have us rewrite things in exponential form and not get too nitpicky with simplifying. This first part of the lesson is just focusing on rewriting the rational expressions and not worrying too much about the simplifying. So something I should have said at the very beginning, but oh well, whatever. We're just making sure we understand that when we rewrite a radical expression, we are using power over root when we change that exponent. Number 3. So we are taking the square root, and you're taking the square root of 42. 42 cannot be simplified with any perfect squares to reduce it, and 42 itself is not a perfect square. So there is nothing to simplify with the 42, and you're also going to notice that the x just has a power of 1, so we are not able to simplify that any further, but you do have a y to the 6th and a z to the 4th power. Now, I could use power over root just to rewrite it, but what you're going to wind up doing is just simplifying and dividing anyway. So the 42, you'll notice in the final answer, the 42 has a 1 over 2, and that's because the power on the 42 was originally the number 1. It didn't have to be printed there. But when you rewrite it using power over root, you will notice in the final answer that the 42 now has a 1/2 as its power. The x that was next to it, I'll put this in the color green, the x also had a power of 1. So when you rewrite that, it would be an x to the power of 1 over 2, and you can't simplify that any further. The remaining two powers of 6 and 4, 6 divided by 2 is going to be 3, and then 4 divided by 2 is going to be 2. So that's why you have a y to the 6th becoming a y cubed and a z to the 4th becoming a z squared. This is now in exponential form, just simplified as much as we can. But those first two terms, the 42 and the x, you couldn't reduce them any further. Let's look at some more examples on the next slide. So in number 4, we are rewriting into exponential form. Maybe take a moment to pause the video and see if you can do it. Same thing with number 5. Just work from the inside out with number 5 and then do a little rewriting with number 4. I'll give you a moment to pause. And okay with number 4. So we're rewriting into exponential form, and right now we are in radical form. So we just have to think about power over root. But what is inside the radical, that entire quantity of x and y, you can think about it as being in its own set of parentheses with the power of 1. Both the x and the y absolutely had the power of 1. But since they both had the power of 1, you can think of them as being in parentheses together, being raised to the first power. And what this allows you to do is a little bit of rewriting using power over root. You can change the power to 1, which would go in the numerator as the power goes, and then the root being 4 is going to go in the denominator. So that leaves you with xy to the power of 1/4. And another way of writing that is the 1/4 could be sort of distributed using the power rule. Since both the x and the y have 1s, the 1/4 could multiply to both of those green number 1s and give you the answer you see right there. It's just another way of writing the same thing. Number 5. So we are simplifying, and again, you want to work from the inside out, simplifying any fractions or reducing any variables with the same base dividing rule that you see. And here we go. So 16 over 2, that's going to reduce to 8. So the 2 canceled with the 16 to give you the 8 that you see right there. And then the x in the denominator cancels with the x in the numerator, so there is no x in the final answer. Lastly, y to the 6th power, because we are dividing by y cubed, you would subtract. So 6 minus 3 is going to give you a y cubed in the numerator. And since there is now nothing in the denominator, we are just left with the number 1. But before we do anything involving power over root, we need to remember we are taking the cube root. And since the number 8 is a perfect cube, we can cube root 8. And since we already have a grouping of 3 y's, we can cancel out those 3 y's and they can come out as a single y. So the cube root of 8 is 2. And the cube root of y cubed comes out as a single y. So we have our answer right there as 2y with no other exponent. I mean, technically the number 1 would be both of those exponents, but you don't have to write that down. All right, let's look at a few more of these. Once again, the same skill set is being applied here, so give the video a pause and set up these examples. Try them on your own before I start explaining and just see how far you can get. They get a little harder as you go through it, and these are going to be the last ones that we'll do. So I'll give you a moment to pause and try them, and then we'll do them together. All right, number 6, here we go. So working from the inside out is where you would want to begin, but there is no fraction here, so we don't exactly have to work from the inside out like we will have to do on number 7. We can start by rewriting the entire thing using that power of 1/2 and basically applying the power of 1/2 to all of these exponents. Because notice from the directions, it's something I didn't state before, we are writing these in exponential form. We're not writing these in radical form right now. It's exponential form. So if you used power over root to get started on number 6, you were already doing the wrong thing, since the direction said simplify into exponential form. So we don't even need to use power over root. Just take that 1/2 and basically distribute it to all the exponents you see. You're going to notice that the front 4, it has a 1/2 because the 4 originally had an exponent of 1. And 1/2 times 1 is just 1/2. The other exponents, we are multiplying here, and you'll notice it says 6 over 2. You should know that 6 is really 6 over 1, and we are multiplying it by 1/2, so that is going to be multiplying straight across 6 over 2, which is going to reduce to the number 3 when we get to the end of the problem. So just simplifying here, the 4 to the power of 1/2, remember that you could think of that as the square root of 4 to the first power, and since 4 is a perfect square, you would actually simplify that to the number 2. If you left it as 4 to the 1/2, you would not be wrong exactly, it just wouldn't be simplified all the way. Next up, the x is going to be an x cubed. You can just leave the y as a 9 over 2, and then the z with a 12 over 2 becomes z to the 6th power. All right, number 7, working from the inside out. Notice that we have a 64, and that is a perfect cube that you have to be aware of. 64 is 4 to the 3rd power. Oops, got an extra page just jumping in there. Let me just back that up. Okay, there we go. 4 cubed is 64. So that's just a number you've got to be aware of in terms of your perfect cubes. So that is going to drop down. But before we do that, we have x's that can be simplified. So you have an x to the 9th in the numerator and an x cubed in the denominator. You would be using the dividing, same base dividing rule. So 9 minus 3 is going to give you 6, and that is why there is an x to the 6th in the numerator. And then for the same reason, you're going to have a y to the 6th in the numerator by doing 11 minus 5. And again, that is because of the same base dividing rule. You are dividing your y's, so therefore you subtract the exponents. The cube root of 64 can now tag along, and we can now start setting up the final answer. The cube root of 64 is just 4. That is a perfect cube that you need to know. And then the x to the 6th, you can think of this as just doing 6 divided by 3. Sure, it is using power over root. You would have 6 over 3, but 6 over 3 just reduces to the number 2. So there is no need to write it that way. Just do that part in your head. 6 divided by 3 is 2, so you get an x squared. And for the exact same reason, you're going to get a y squared, and anything divided by 1 is itself. So we have the answer right there, 4x squared y squared. Number 8, once again, working from the inside out. Ignore the 4th root until the very end. The x to the 8th can be subtracted by 2 because there's an x squared in the denominator. So 8 minus 2 is going to be 6. And then y to the 6th can just tag along. There was nothing to simplify with it. Take a look at that denominator, though. There is a z to the power of negative 2. We haven't had a negative exponent come up yet, but as a reminder for what needs to happen, you flip and switch a negative exponent's position. The z to the power of negative 2 is going to flip from the denominator up to the numerator. Take a look at down below. There is no longer a z to the negative 2nd power in the denominator. It has now been moved to the numerator. It has flipped to its numerator position. And then the negative exponent switches to positive. So it is now a positive 2 in the numerator. And then the only thing left over was the 2 and the 3. You didn't need to do anything to it. And then the 4th root symbol. Really quickly, though, just to illustrate that negative exponent point, one last time, let's just say that y actually had a negative 6 as its exponent. That means the y would have had to move to the denominator and then the 6 would have become positive. And that was, again, if it said y to the negative 6th power instead, just to review that negative exponent rule. We are almost done. We are supposed to write things into exponential form. So take the 2/3 and make it its own fraction. Both the 2 and the 3 have powers of 1. So the power is 1, the root is 4, and you would have 2/3 to the 1/4 power. And then you can just do the exact same thing with your remaining variables. Notice how x to the 6th power now has a 4 as its denominator. Same thing for the y, and then same thing for the z. Simplify those exponents, and you will have what you see down here in the final answer in green. Lastly, number 9. So you are going to start off just like you did with number 6 by distributing the 1/5 power. We're not rewriting with power over root. The directions said to write things in exponential form, and we already have things in exponential form, just like with number 6. But 32 is the one perfect fifth that you should know. 32 is really 2 to the 5th power, and since that is a perfect fifth, and you are going to be getting 32 to the power of 1/5, you can just go ahead and rewrite that as the number 2, because that is how you would ultimately be simplifying it. Next, just do power over root with the remaining variables. You're going to have an x to the power of 7 over 5, a y to the power of 2, because it would have originally said y to the power of 10 over 5, and 10 over 5 would just reduce to 2. And then z to the 13th would become z to the 13 over 5th power. And that's all the simplifying you can do with that one. So we have done all that we need to do. All right, so the last thing I'm just going to show you are a few more questions that will ultimately become the Bellwork on the next video. But what you can do right now is give these 3 questions a shot just one more time. I'll flash the answers and we'll talk about them in the next video. So maybe just pause, give them a shot. And here we go with the answers, and there they are across the bottom. Thanks for watching the video. I'll see you in the next one.